Hello everyone, welcome to my channel. Today we are solving path sum. So we are given a root of a binary tree and also a target sum. We're going to return true if the tree has a path from root to leaf that add up to the target sum that's given. So for this example, we have a target sum of 22 and there is a path from the root 5 to the leaf 2. And if you add up all the numbers, 9, 20, 22, the number will add up to the target sum. So there's a valid path, so we are going to return true. So we are going to use recursion to solve this problem. And every time the function is called, we are going to subtract the current value from the target sum. So in this case, 22 minus 5, which is 17. And we're going to use that to call another function for the left and the right children. So we're going to subtract the current value from the new value that we got. So we're going to have 13 here. And then we're going to use that to call this function. So we have 13 minus 11, which is 2. And then we'll call this function using 2. So 2 minus 7 is negative 5. And once we reach the leaf, we're going to check if the number that we have is equal to 0. So in this case, it's not. So we are going to return false. And then we're going to check the other side, the right subtree. So we're going to use 2, and 2 minus 2 is 0. So when the value is 0, it means this path, the values add up to the target sum. So we are going to return true. And once we go back to the previous function, we are going to check the left and the right subtree. And if one of them is true, we are going to return true. And also if we have null node for one of the sides, we are going to return false. And we have true for one side, so this is going to return true. And this will return false, false. And if they're both false, it will return false. And we're going to check left and the right for each recursion. One of them is true, so we're going to return true. That is basically it. So let's write up the solution. The first thing we need to do is to have a base case for the recursion. So the root node can reach null when the previous node doesn't have either the right child or the left child. So in that case, we are going to check if the root is null. We are going to return false. Next, we need to check when the node is a leaf node. And we are going to check if the number that we have that we kept subtracting, and if that's equal to 0. If it is 0, then it is a valid path. So we're going to return true, otherwise we're going to return false. So we can check if it's a leaf node by checking the left and the right child. So if the left child is null and also the right child is null, in that case we are going to check if the number is equal to 0. So we are going to subtract, again we're going to do the operation one last time. So we are going to do target sum minus the current value is equal to 0. And every time we're also going to call this function with the left child and the right child. And let's do that. So has pass sum, and we're going to call the left child, and every time we're going to subtract the target number with the current value. So target sum minus the current value, which is root.val. And we're also going to call the function with the right child. So path has pass sum with root.right. Again, we're going to subtract the current value from the target sum. And we're going to return true if either one of them, either left or the right function, returns true. So we are going to use an OR operation. So that is basically it. So let's see if this works. Alright, great. So this was pass sum. Thank you for watching.